Page 8 of solids. Find an expression for the volume V of each solid. Give each answer in its simplest form. Okay, so just look on your formula sheet, and for a pyramid, a square pyramid, basically it's 1/3 base times height, um, and so that would be 1/3, and the base here would be x times x, which is x squared, and the height would be h. So that's it. Okay, that's A. Now for B, it's a cylinder, so it would be pi r squared times the height. So it would be pi times r, which is x, squared, times the height, which is 2x. So we'll write pi times, we'll put 2 pi x cubed for B. Okay, and then the next one is also a cylinder. So it would be pi r squared times h, where r is, let's see, it's 6x across all the way, so the diameter would be 6x, but the radius would be 3x, so it would be 3x squared. And then the height would be x, so that would be pi times 9 times x squared times x, so it would be equal to 9 pi x cubed. Now D. It's a sphere, so it would be 4/3 pi r cubed. And then r in this case is, the diameter is 3x, so the r would be 1.5x, so it would be 4/3 pi 1.5 x cubed. So 1.5 cubed, we could also write that as 3/2 cubed, so it would be 4/3 times 3/2 cubed times pi times x cubed. So 3 cubed, or that would be 3 cubed would be 27, divided by 3 is 9. 2 in the bottom cubed would be 8, so it would be 2. So 9/2 pi x cubed. Okay. 5. A spherical ball has a volume 200 centimeters cubed. Find the radius of the ball. Okay, so it's basically 4/3 pi r cubed is equal to 200. So let's find the radius. So let's see. It would be r cubed equals 200 divided by pi times 3/4. Ugh. Okay. By the way, 200 times 3/4 would be 150. So it's 150 divided by pi. 150 divided by 3.14 is 47.8. So r would be the cube root of that. Let's see. This to the 1/3 power is 3.63. Okay, find the radius of the ball, 3.63 centimeters. Give your answer in part A correct to the nearest millimeter. So that would be equal to 36 millimeters. Okay, we would chop off the R, the 3. Okay, 7. A cylindrical pencil is 13.5 centimeters long with a diameter of 0.7 centimeters. It is sharpened to a cone as shown in the diagram. The length of the cylindrical part is now 12.3 centimeters. So this part here is 12.3. The height of the cone is h, and its slant height is 1 centimeter. Write down the value of h So, well, we know that the whole thing is 13.5 and the cylindrical part is 12.3. So we could find h by doing 13.5 minus 12.3. So that gives us 1.2, right? 1.2 centimeters. Oh, I'm sorry, it doesn't say slant height is 1, it says slant height is L. Okay, now find the value of L. Well, if we draw a little picture here of the cone, the cross section of the cone, we know that the height of the cone is 1.2, and we know this part is L. This part, the base of this triangle would be 0.35, right? So now we can use Pythagorean theorem to find L. L would be equal to the square root of 0.35 squared plus 1.2 squared. So let's find that. 0.35 squared plus 1.2 squared. And then we could take the square root of that to find the slant height, which is 1.25. Okay, 1.25. All right. Hence find the total surface area of the pencil and the volume of the pencil. The total surface area of the pencil. So the total surface area of the pencil will be made up by the end and the wrapped around part and the cone part. Okay, so the end part would be pi r squared, and the r in this case is 0.35. And then the wrapped around part would be 2 pi r, and the r here would be 0.35, and times the length of the cylindrical part, which is 12.3. And the cone part would be pi rl, where L is the slant height. So it would be pi times 0.35 times L, the slant height would be 1.25. Okay, so just multiply all that out, and that will give you the total surface area of the pencil. What about the volume of the pencil? So the volume of the pencil would be the cylindrical part plus the cone part. So the cylindrical part would be pi r squared, 0.35 squared, times the length, which is 12.3. And then we would add the cone part. The cone part would be 1/3 pi r squared, 0.35 squared, times the height, which is 1.2. Okay? Just multiply all that out. The pencils are packed in boxes. The boxes are cuboids of width 5.6, height 1.4, and length 13.5. Show that the maximum number of pencils that will fit in the box is 16. Okay, so it looks like the length is exactly right for the pencils. So let's just figure out, let's draw a box, the cross section, 5.6 and 1.4, and then we'll see that the height-wise, each pencil is 0.7 in diameter, so in 1.4 you could put 2 pencils. And then the width-wise, you could put 8 pencils across, 2, 3, 4, 5, 6, 7, 8. And then it would fit perfectly, although my drawing is terrible. Okay, so you could put 8 across here, and then you could put 2 here. So yeah, that would be maximum of 16. Find the space in a full box that is not occupied by the pencils. Okay, so to find that, what you could do is you could find the volume of the total box, which would be 1.4 times 5.6 times 13.5. And then you could take your answer from, so that would be the volume of the box. And then you could take your answer from B2, which we don't have yet, but we could take our answer from B2, which would be the volume of the pencil. We could multiply it times 8, and then we could get this number, and then we'll subtract it from that, and then we'll get the volume that is not occupied by pencils. Write your answer to volume D as a percentage of the volume of the box. Okay, and then you would just take your the percentage that is not occupied and divide it by the total volume of the box to get E. And that's it.